Hello. This is a quick demo of a financial system that I've been working on here and there on my free time. And uh, to start with, we have as at the core a bank application. Obviously, you can create accounts, you can register with it, and interact with other applications in this architecture. Um, to start with, let's go with the teller. And we have a help application. This is like if you go to a bank and you interact with the teller, she might be using a WPF application that is helping her uh, log in as an administrator, pull out money out of your account, make transactions, create accounts for you. In synthesis, do the things a teller will be doing in a real life scenario. The other interactions that we have in this system is a bank-to-bank transaction, and this is done through a clearinghouse where, uh, let me clarify that we have three different um, OAuth service. On purposely, I created uh, different versions just to manage the transactions that were happening in a real life scenario. At least that's how I see it mostly. Not every system is going to have a centralized OAuth to authenticate. Um, and so client, the bank, the requester bank or the sender bank sends the transaction to the clearinghouse. The clearinghouse identifies ID of the bank, see if it has it. If it has it, sends the transaction. The bank checks itself if it has the user and if the user have enough resources to finish the transaction. Send the response backs, and in this case, well, it's not the ticket, right? The transaction, the way I have it set up is that usually you have a transaction that it doesn't clear right away. So once it is confirmed, the transaction is set on a 200, not 200, 204 I think it is. It is a created transaction, and this sets a transaction itself as processing, and this creates a timer to allow it to sleep and not to release it for on a random scenario between 30 and 2 minutes, within 30 seconds and 2 minutes, so that the bank keeps on trying and allow the flow to be interrupted. I break this flow of checking back if the transaction has been approved by but has been released by having a quartz job that every 30 seconds, once a transaction has been done with a particular bank, it's gonna check on that bank to release all the transactions, and you're just gonna keep on checking till all the transactions are released. Um, Another interaction that we have here is the business, third-party business, and this is simple. To put it simply, we have a business that has a bunch of point-of-sale devices everywhere, restaurants, gas stations, coffee shops, and as a user, you send your bank information, right? In this case, I'm just sending the UI, the GUI ID of the bank account, and the the point itself as its identification set the amount that is going to be charged, and it sends it to a RavenQ queue. There is 20 of these devices, so I added a queue to prevent overflow, and I don't want to have unnecessary replication going on for this simple transaction. So it is queue. Also, there is also risk of transactions being lost. So again, I added a queue to prevent that. The device, the third-party business receives the information once it gets it, identify who sent it based on the IDs, adds a 5% charge to the transaction, and identify itself again using the client workflow with the the bank rejects it or approve it. The way how it set up is if you have an account that like a credit card and you have over the limit, it's not going to be processed. If you have a checking account, for instance, if it is overdraft, you're not going to be able to use it. You have the transactions going to leave you negative. So in this case, approve it, right? The transaction deposit accounts into the deposit. So the transaction itself handled. So the third-party business has to be registered with an account so that this a debit. So let's say that you have one account getting 5 and the other one is being taken those 5, so they have to match for auditing purposes within the account. Moving on, the transaction is sent back. The user gets a response. Obviously, this goes through the wrapping queue, and the user receives the approval or denial, and it gets a final amount that was charged. So whatever was generated, so I have like a minimum and open bound, but depending on the business, and the 5% charge. And can give you a quick overview. So the application itself is running in Kubernetes. It is a containerized application, and what you're seeing here, in case you're not familiar, it is Argo CD. Argo CD is helping you in continuous delivery to maintain the application up to date. Let me, I think this is, let me give you another demonstration, because what's going on is a bit weird depending on the system, because the system they have it set up. Let's say that we push to GitHub, push a commit. The commit, Argo CD, it is running out of Kubernetes cluster. The whole system is running out of 7 node Kubernetes cluster, and this is on a private subnet. So it accepts egress, it doesn't accept ingress. So GitHub can now notify Argo CD, I apologize, Jenkins of a new commit. Jenkins has to go and check because again it doesn't accept increases, on accept it doesn't accept increases, on accept egress network request. So it checks every 6 hours. This Jenkins is gonna build the request, and what it does is build the project. So let's say that is the core. The core has a few unit tests I have to run. Once that the test is the one that is triggered, the next application itself is the core application, and it creates a Docker image and it pushes to Docker. There is, within the Kubernetes cluster, there is a helper that checks every so often if there is a new image, and it notifies Argo CD that it can pull that image, and that is a way how it keeps itself up to date and on the real release. Obviously, if there is a failure, Argo CD and Kubernetes keep track of the last few releases, so it can go back. It's set up as to use the Canary deployment. So this is the cluster itself, and this is a the Argo Jenkins pipelines. So we have the test here. We have the test, and this is what kicks the other builds. We have the bank core, clearinghouse, international bank. That's for the secondary bank that I have. Point of sale processor, and registered businesses. The teller, and here for instance we have a few businesses. I scale it back to only 3. I have too many running around and just were consuming a lot of resources within the cluster. But I have gas bill, electric bill, and internet bills, and again they just hit and interact with the third-party business. Here we we have a failure. Okay, so this looks to be from a cron job. I added a few cron job and I edited it some time ago. So they apparently created some issues with the backup, and the cron job every week is gonna be doing a backup of the databases, and it's gonna be storing it on another server that I have, just to keep the data. Obviously, it's not necessary for this type of application. I just want to do the whole process. You can see everything that is running within this namespace, and we have the client application. This is an older version. We have the core bank account, bank application. We have a Postgres DB, and you can see here the claims for the space. The way how it's set up is that within the cluster I have two nodes that have SSDs, and they're marked, and whenever I have a claim for space, these are the nodes that are being called. The client, this is another, so, and rather include a claim. I only have one space allocated for it, since it's not keeping a lot of things going on right now. What else was the application itself? So this is the application. Let me log out. And like I mentioned, the application is running on React. And here I'm going to take myself against user credentials to the entity server. We have a homepage, just a set of account summaries. These are some accounts I have created. Have credit cards, checking accounts, car loans, and you can click on them, go into further information, see the transactions that are happening. I need to fix a day here. I made a change to the day format, and that has cost me some pains. Here you can do the bank-to-bank transaction workflow. These two are not doing any HTTP requests. These are just drafts that I made just so I can have an idea of where I'm going to. These are dynamic. I can change the type of card that is presented, and I want to have some type of information based on the transactions that are happening. But this will require some type of cron job to run every so often to keep some useful data for the user here. And this is pay bills. This is a working process. I haven't fully decided what I want to do here. I have an idea what information I want to collect, and I just put as I was thinking, a flexbox and putting everything together within it, so it wobbles a lot since it doesn't have a lot of thinking through how things are going to happen. You can pay it, you can edit it. This doesn't go anywhere. It's not submitting any data. You can delete it, but again, this is only on the UI. Yeah, this is just about my page. Quick overview. So this is the UI itself. Again, running in React. I chose React because I've been working too much with Angular in the last few months, and decided to just pick one or the other and work with React. This is the application. The application is using DDD to separate the concerns. We have a few layers here. We have the identity layer, we have a persistence layer, unit tests that I'm running, and application level and API. Also, the application is running with CQRS. Can probably show your controller, give you a more grounded view. For instance, let's see if we will have a good transaction. Okay, so this one right here, for instance, we have deposit, right? And most of the controllers that you could see as I was scrolling and moving are relatively simple. They only send the request going to the next to be handled by a secret. In this case, we're doing a deposit. It just gets information and sends it back depending on whether or not it fails to the next request. And on this workflow, this is pretty much what I've been doing. If it gets to the situation where I'm doing more than one, excuse me, more than two, if I'm posting more than one to the queue, I usually try to divide it into its own request handler. Here, and this is something that gave me considerable pains, you can see that on the transaction, this is not usually how it's handled if you have used MediaArt by any time. So I am sending a DTO and I'm receiving a DTO as a response. The problem is that because I want to handle allow the data, you can see here that the TDTO, and this is the main database, and this is DTO, is not handled by itself on the request. And this cost me a lot of pain to understand how excuse me, how secrets, MediaD, and the framework was handling this particular generic class. And again, it's not using it, but because the handler, let's see, I have too many calls here for this particular class. So application, request handlers, commands, indices, generic, create. So because when we call it, the T entity is being instantiated through the handler, is going to create conflict because it doesn't know about the T entity. So you have to pass it even though it's not going to be used by the request itself, but by the handler. So it looks a little weird, but it's the only way how this can work, where I can have generic handlers and work through the workflow where I can call the mappers, the DB, and move around the different types of classes on this system. Again, this is something I've just been doing to keep on working on my free time and doing some experimentation, just thinking through how some finances work. And yeah, please let me know if you have any questions and or concerns. Thank you.